Okay, so for today's video, we're going to do some examples of what we did in the previous video, which will be fractions, mixed numbers, and improper fractions. I'm going to start with simplifying 6 different fractions, then we'll work on converting mixed numbers to improper fractions, and we'll have 6 examples of those. And then we will convert improper fractions to mixed numbers, and we'll have 6 examples of those. But for right now, we're going to start with simplifying fractions. So I'm going to have six examples for us. And the first example we're going to have is 25 over 60. And so when we want to simplify fractions, what we do first is we take the prime factorization of the numerator and the denominator. And we'll see that 25 simplifies to 5 times 5. And 60 simplifies to 5 times 12. At this moment, we notice we have a 5 in the top and a 5 in the bottom, so we can cancel those out. And then we are left with 5 twelfths. Now, the next problem we'll be working on is 22 over 44. Okay, and so to simplify this one, we'll do the same thing. We're going to look at our numerator, which is 22, and we'll see that it can simplify to be, actually not simplify, but we can write it as 2 times 11. And then our denominator, we can write it as 2 times 2 times 11. Keep in mind that 44, and this is just a small tangent, 44 is 4 times 11, and then the 4 can be separated into 2 times 2. And so that's why we have 2 times 2 times 11. Now here, I'm going to switch to red. We'll see that one of the 2's will cancel, and that the 11 will cancel. And so in this case, what we have left on top is actually a 1. The reason for that is these 2's, when we simplify them, they turn into a giant 1. And I didn't draw that correctly. They turn into a giant 1. And that's the same for the 11. They turn into a giant 1. And the reason for that is 2 divided by 2 is 1, and 11 divided by 11 is 1. And so what we're left on top is 1 times 1, technically, since what we have on top and bottom is 1 times 1. And then on the bottom, we're left with 2 times 1 times 1, which then simplifies to 1/2. Okay. The next example we're going to have is 55 over 72. And so what we'll see from our prime factorization of the top is we have 5 times 11. And then on the bottom, we have 72, which can simplify down to 8 times 9. 9 is 3 times 3, and 8 is 2 times 2 times 2. So it comes out to 2 times 2 times 2 times 3 times 3. Remember, this portion is an 8. 2 times 2 times 2 gets us to 8. This portion is 9. And so then 8 times 9 gets us to 72. But we run into a little bit of a problem here, don't we? There's nothing to simplify. We have a 5 and 11 on top, but we only have 2's and 3's on the bottom. So since there's nothing to simplify, our fraction is already simplified, and it remains as 55 over 72. Okay. Our next example, I'll move down to a new page here, will be 38 over 60. All right. 38, we can simplify it as 2 times 19. You want to double check to make sure that works. 19 plus 19, well, that's 10 plus 10 is 20. 9 plus 9 is 18. 20 plus 18 is 38. And then on the bottom, we have 2 times 5 times 2 times 3. Yes. Yeah. And so the reason for that is 2 times 5 is 10, 2 times 3 is 6, and 10 times 6 gets us to 60. And so what we notice is there's only one thing that can cancel out here, which is this 2. It turns into a giant 1, and we are left with 19 on the top. And 2 times 3 is 6, times 5 is 30. And so we have 19 over 30. Okay. The next example we have is 37 over 60. And so on the bottom, we still have our 2 times 5 times 2 times 3, or whichever way you want to write it. Order technically doesn't matter here. But 37 is an interesting number. Not only is it odd, which can make it interesting, but it's also prime. And so as we remember from our previous video, a prime number has only factors 1 and itself. And so that means the top is only 1 times 37. And since our top factor is only 1 and 37, and our bottom factors are a 2 2s and a 3 and a 5, we have nothing in common. And so that means our fraction is already simplified. So we have 37 over 60. We'll have one more example of simplifying fractions. Here's the last one. It is 80 over 92. Okay. Now, in this case, I'm going to work this one out a little bit more. 80, I know, is 8 times 10, right? And I know that 8 itself is 2 times 2 times 2. And I know that 10 is 2 times 5. Okay. 92, I know that that is 2 times 46, I believe. And 46, I know, is 2 times 23. Right, any even number can always be divided by 2, and we're left with 23 in this case. So to write this out in entirety, or in its simplest fractions, we have 2 times 2 times 2 times 2 times 5 on the top. And then on the bottom, we have 2 times 2 times 23. Now on to simplifying this out. One pair of 2's cancel, another pair of 2's cancel. And on the top, we are left with 2 times 2 is 4, times 5 is 20. And in the denominator on the bottom, it is 23 is left over. So our answer is 20 over 23. Okay, that's simplifying fractions. What I'm going to do now is the next set of this video, the next third of this video, which will be converting mixed numbers to fractions. And I ran out of room. Oh well. Okay. So I'm going to give you a set of problems here and we'll work them out as we go. So the first problem is 4 1/5. The next problem is 2 3/8. The next problem is 5 2/7. The next problem after that will be 105 3/5. The next problem after that will be 23 7/8. And the last problem will be 19 1/8. Okay. So if you want to work these out ahead of time, you can. But I'll start at the beginning. I'm going to do 4 1/5. Now, to convert mixed numbers to improper fractions, we need to remember a little trick from our previous video. You want to multiply the denominator and the large whole number, and then whatever you get there, you want to add the numerator back to the number you get, and that'll be your new numerator. So in this case, I'm going to look first at, well, what is 4 times 5? And so I'm going to use red for this. So 4 times 5 gets me to be 20. Then I need to add the 1. And so 20 plus 1 gets me to be 21. And then what I'm left with is 21 over 5. The denominator stays the same. Our numerator is the only one that changes. And so now we're left with 21 over 5. Now we can do the same thing here. I'm going to simplify it a bit. 8 times 2 is 16. Plus the 3 now, we get 19. And so we are left with 19 over 8. Okay. 5 2/7, our third problem. 5 times 7, what is that? That's 35. Plus the 2, we get to 37. And so we get 37 over 7. And that's the fraction that we get. Now on to a big one. 105 3/5. Okay. 105 3/5. So 105 times 5. That's a big number. Well, we can work this out manually, and I'll go ahead and do that. There's also a little math trick you can do, but I'll go ahead and work it out on the side here. So 105 times 5. 5 times 5 is 25. Carry the 2. 5 times 0 is 0 plus the 2. We get 2. 5 times 1 is 5. So we're left with 525. And then adding the 3, we get 528. And then in our denominator, we're left with a 5. Okay. Next one is 23 7/8. So we need to know what 23 times 8 is. I don't know that immediately off the top of my head, so I'm going to go ahead and work that one out. So we're going to have 23 times 8. 8 times 3 is 24. Carry the 2. 8 times 2 is 16, plus 2 more is 184. Okay. Now adding 7, we get 191. And so on the top, we're left with 191 over 8. Fortunately, my 9 is not very good there. But it's 191 over 8. Alright. Last set now. Last problem. 19 and 1/8. So what we can do here is we can work it out on the side. 19 times 8. 8 times 9 is 72. Carry the 7. 8 times 1 is 8. Plus 7 more is 152. And so then we have 152 from our multiplication. It's hard to write small on this. And then if I carry 1 more, I get 153. So in my numerator, I now have 153 over 8. Awesome. All right, so that takes care of 6 problems of converting mixed numbers to improper fractions, or just to fractions in general. Now what we're going to do is we're going to do the opposite. We're going to convert fractions to mixed numbers. Okay. And so I'm going to give you 6 problems, and then we'll work them out separately. The first one we'll deal with, and I want to make sure I have a little bit of room for this, I'm going to have 40 over 3. Next one is 80 over 7. Next one is 60 over 5. Next one after that is 152 over 9. Next one after that, I'm going to go down to a new page here, is 183 over 17. And then the last problem we'll work on today is 147 over 15. All right, those are the 6 problems you have. If you want to do them ahead of time, you can, and then check your answers. But I'm going to work my way back up, and I'm going to start with 40 over 3. Okay, so we need to quickly remind ourselves how to convert fractions to mixed numbers, and the simplest way to do that is to divide it out. So we're going to say, how many times does 3 go into 40? Well, 3 goes into 4 one time. I get 1 times 3 is 3, and then 4 minus 3 now is 10. Bring down the 0. Technically, 4 minus 3 is 1, bring down the 0, now you get 10. Was a little ahead of myself. Now, how many times does 3 go into 10? Well, it goes in 3 times. And we get 9. Simplify that, and we get... Actually, we don't get 10 again, sorry, I was a little ahead there. But we are left with a 1. And so then the answer here becomes, in this case, 13 is the whole number, 1 is our numerator, and 3 is our denominator. So we're left with 13 and 1/3. Okay, I'm going to erase a portion of this so that way I can get some of my space back. Thought I had enough room, but I guess not. That's always fun when you divide. Okay, so for 80 over 7 now, we're going to do the same thing. I'm actually going to shift out a bit here. I'm going to do it over in the far right side here. We're going to have 7 on the outside, 80 on inside the house. So how many times does 7 go into 8? It goes in once. I get 7, subtract it, I get 10. It goes in once again, I get 7. I'm left with 3. Okay, so in this case, my answer is 11, which is the whole part. The 3 that's remaining, that portion that's remaining, that's my numerator, because it's the part of the whole that I'm looking at. And 7 is my denominator, so it remains the same. 11 and 3/7. Yeah. Alright, now on to 60 over 5. Yep, 60 over 5, cool. Okay, so in this case, 60 over 5, we're going to have 5 on the outside, 60 on the inside. And so now 5 goes into 6 once, I get 5 left over, I get 10, 5 goes into 10 2 times, and just like that, I now am no longer subtracting anything and I get 0, which means my whole answer is 12. There's nothing left. Okay. Now on to 152 over 9. 152 over 9. Okay. So we're going to have 9 on the outside, 152 on the inside. 9 goes into 15 once. I get 9 left over. 15 minus 9 is 6. Carry the 2. Or bring down the 2, sorry. 9 goes into 62 how many times? That's quite a bit. I believe 9 times... Sorry, I was thinking for a moment. What was it? 9 times 6 is 54. 9 times 7 is 63, so it's 9 times 6. Whoops. $54 here. Subtract that, I get 6 left over. And from there now, my answer becomes 16 and 6/9. Or actually, sorry, no wait, never mind. I messed up. This guy down here, 62 minus 54, I was hearing something in the background, but it's okay. 62 minus 54 is 8, not 6. And that means I just need to remove this. And I get 8/9. There we go. Now it lines up with my notes that I'm looking at part of the time. Okay, next problem. Next problem is 183 over 17. And so in this case, I'm going to get 17, whoops. Want to make sure that I'm using the right one. 17 over 183. 183 is inside the house. 17 goes into 18 once. I'm left with 17. Subtract that out, I get 13. Now, here's where you have to do something interesting. We still have 13. We don't have any other numbers besides the 3. So we have to bring down the 3 and we have to say, how many times does 17 go into 13? Well, it goes in 0 times. And then from there, we stop. 17 times 0 is 0. Subtract that out, still left with 13. So in this case, our answer becomes 10 and 13/17. Once again, the reason for that is we started with 183. We said, how many times does 17 go into 18? It goes in ones. So we subtract 17, we get 1 left over, bring down the 3. At that moment, we have to deal with this 3 now. And we have to say, okay, now that we have 13, how many times does 17 go into 13? It goes in 0 times. And so that way, if we remember from elementary school, this number on top now lines up with the number of digits that was in our numerator. Can't remember if it's dividend or divider, but it's in our numerator. And so now that we've taken care of the ones place and the tens place, now we can stop. And so then our answer is 10 and 13/17. Okay, last problem. $15 goes outside the house. 147 goes inside the house. Now this is really kind of annoying because 15 doesn't go into 1. 15 can't go into 14, but it can go into 147. Now, I'll give you a hint. 15 times 10 is 150. So, clearly that's one too many. So let's do 15 times 9. If we work this out on the side, we get 15 times 9. We get 5 times 9 is 45. 9 times 1 is 9, plus 4 is 135. So we get 9 on the top. Well, that came out completely wrong. 9 on the top. 135 on the bottom. Subtracting that out, I get 12. Okay. So now, my answer in this case is 9 and 12/15. However, there's something we can do here. 12/15. Could we simplify that? Keep in mind that I'm going to use a little bit more space here. 12 over 15 is equal to 4 times 3 over 5 times 3. Notice how we can both cancel out the 3 here. And so in this case, 9 and 12/15 can also be 9 and 4/5. And that is your answer. Sometimes your textbooks may say that both of them are the answer. Other times they'll say simplify if possible, or always leave your answers in simplest terms. And so if they say to simplify it in simplest terms, then your answer is 9 and 4/5. Okay. But technically both of them are correct. But I'll leave that up to your textbooks and to your teachers. Other than that, that is the end of this video.